Okay, so now you know how how to do differentiation the long way with that weird big function. Now let's look at some of the derivatives that we already know for sure. I won't show you the proofs now. I'll upload the proofs separately, but let's just look at the derivatives and how to use them. So for polynomials are like stuff like x squared, x cubed. We're just looking at this sort of stuff for now. So for polynomials, we say that d by dx, which is the differentiation of x to the power of n, is equal to n x to the power of n minus 1. So for example, if you have x squared and you're taking the differentiation, if you're taking the derivative of that, then that becomes, we take 2, we put it down, so you get 2x to the power of 1, because 2 minus 1 is 1. Yeah, similarly, d by dx of x fifth is equal to 5x to the power of 4, using the same method. Next, let's look at trigonometric. Ooh, that's a fun one because it is really it's kind of weird to memorize. So yes, a trigonometric, that is, so if you're doing d by dx of sine x, then that becomes cosine x. Then if you do cosine x, that becomes minus sine x. And if you have minus sine x, once again, that becomes minus cosine x, because that's a rule that you'll learn later about differentiation. That's fine. So I'll just write it down for you. D by dx of minus sine x is equal to minus cosine x, and then here it goes back to the top, because once you differentiate this, you get sine once again. Then if we go to exponential, that's exponential. Oh great, no, I didn't even finish your trigonometric for you. What a jerk I am. So okay, now if you have tan x, so really trigonometric differentiations, they're in groups. So we have the sine cos group, then we have the tan secant group, because if you differentiate tan x, that gives you secant squared x. If you differentiate secant x, that gives you secant times tan x. So that's why these two are a group again. And then similar is for cotangent and and cosecant. So if you differentiate cot, then here instead it's a little they try to trick you, because now it's really minus cosecant squared x. And if you do d by dx of that other one, what is it, cosecant x, that becomes minus cosecant x cot x. So it just so it's like this but negative. Now we can look at now we can look at exponential. I know you have been waiting for this but yeah, now we get exponential. So if we have d by dx of e to the power of x, then here, surprisingly, that's still equal to e to the power of x. And if you have d by dx of like some random number a to the power of x, then that becomes ln a, like ln a times a to the power of x. Then if you look at logarithms, with logarithms, you have if you do d by dx of ln x, then you get what you get. You get 1 over x. This is an x, okay? Yeah, 1 over x. Then d by dx of like log base b of x. Then you get 1 over x log ln b. This is because of this rule with exponents. So like if you, because the rule is that log b of a is equal to ln a over ln b, and that's why we could do this. And yeah, that's all you need to know. And then lastly, inverse trigonometric. This is a real pain. Like, it's so bad because it's hard to remember. So let's start with a simple one, which is the tangent. How do I draw it? Yeah, arctan. Sorry, I meant arctan of x. And that if you do that, then you get 1 over x squared plus 1. So this is the easy one right here. Then d by dx of sine arcsine x. Yeah, so this is equal to 1 over square root of 1 minus x squared. And like once you learn the techniques to prove this, it'll like make much more sense. And d by dx of arc cos x is equal to minus 1 over square root of 1 minus x squared. So there you have it. Those are the derivatives for most of the simple functions. And thanks for watching this video.